Okay, now we're going to combine what we know about SN1 and SN2 reactions, and we're going to use it to describe a transformation. We're going to convert an alcohol into an alkyl halide now. Okay? So we're going to show two examples of this with two different substrates. So our first substrate is going to be a tertiary alcohol. And I'll show you the overall reaction first, and then we'll go over the mechanism. So we're going to take a tertiary alcohol, and we're going to use HCl, concentrated HCl. And what that's going to do is it's going to replace the OH. We're going to do a substitution reaction, and we're going to replace it with chlorine. So we're converting an alcohol into an alkyl chloride. Okay? So the overall mechanism for this, first we need to look at our starting substrate. So what is our leaving group now? So our leaving group here is going to be OH. And so we know good leaving groups tend to be conjugate bases of strong acids. So OH is a fairly strong base, so it's not going to act as a good leaving group. So we have to do something first in order to convert it into a good leaving group. So what we're going to do is we're going to do a proton transfer. So we're going to take a proton from our HCl, and we're going to protonate our alcohol. So in the first step, let's go ahead and draw that. All right, so HCl exists as, usually we can draw this out as H3O plus and chloride minus. Okay, so in the very first step, we are going to use a lone pair on the hydroxyl group to make a bond to hydrogen, and then we're going to take the OH bond and turn it into a lone pair on oxygen. Okay? So this is an acid-base reaction, and these are generally reversible. So as we do this, what do we get? We end up with a protonated alcohol. We end up with water. I'm going to put it in parentheses because we're not too interested in that right now. And chloride. Okay? So we have a tertiary substrate here. We now have generated a good leaving group. So now we need to think about what mechanism works best with tertiary centers. So we can't do an SN2 reaction on this because we don't have the room for a backside attack approaching the leaving group with chloride. So what we're going to do instead is we're going to do an SN1 reaction, and this SN1 reaction is going to involve loss of a leaving group first. So we'll go ahead and draw that, where now water is going to leave. So we're only going to need one mechanism arrow to show that. So we're going to break the carbon-oxygen bond, turn it into a lone pair on water, and then water will leave. So we're going to form a carbocation. We're going to form another equivalent of water. And again, chloride is still waiting around, ready to react. Okay? So in the next step of this reaction, we've lost our leaving group. Now we can have nucleophilic attack. So here, chloride is going to make a bond with one of its lone pairs between chlorine and carbon. And that's going to lead us to our final product. We have carbon, a chlorine substituent, and the byproduct of this was water, which was our leaving group. Okay? So if we look through this mechanism, we had 3 steps, and each of these is one of our fundamental reactions. So here we had a proton transfer. So we used the proton transfer to convert OH into a good leaving group. Once we had a good leaving group, H2O plus could leave as neutral water, so we had loss of a leaving group. And finally, in the last step, we had chlorine or chloride. Our chloride ion is going to attack our carbocation, and then that is a nucleophilic attack. Okay? So converting a tertiary alcohol into a tertiary chloride, we're going to go by an SN1 mechanism, where first we activate the alcohol by protonation, so we're going to do a proton transfer to make a good leaving group, and then our SN1 reaction can follow. Okay? So our second substrate, instead of a tertiary alcohol that we had up here, we're going to use ethanol. And ethanol is a primary alcohol. And so, again, we're going to treat that with HCl. And what that's going to do is it's going to convert our alcohol into an alkyl chloride. Okay? So again, let's think about our substrate here. It's primary. We don't have a good leaving group, right? Because OH we know is a bad leaving group. So we're going to have to activate it so that it's a good leaving group. Because it's a primary substrate, we're going to want to do an SN2 reaction. So this time, we're going to take our alcohol, and we're going to give it H3O plus and HCl to work with, or chloride to work with, right? So very first step of this mechanism, we're going to take a lone pair on oxygen, going to make a new bond to hydrogen, break the OH bond to generate neutral water. So now we have a protonated alcohol here, which is now a good leaving group, as well as one equivalent of water from our acid and our chloride anion. Okay? The next step, because it's an SN2 reaction, we're going to have chloride do nucleophilic attack on the backside of this carbon leaving group bond. And then we're going to break the carbon-oxygen bond so that we generate neutral water as a leaving group. So here, we generate a new carbon-chlorine bond and another equivalent of water as our leaving group. So if we're to categorize all the steps in this reaction, and our very first step, again, is just a proton transfer. Right? We're moving a hydrogen H plus ion to the alcohol to turn it into a good leaving group. Once we form this good leaving group, we can go ahead and do our SN2 reaction. So here we have two arrows. So our first arrow is our nucleophilic attack step. Our second arrow is our loss of leaving group. Right? Because it's an SN2 reaction, these two arrows happen simultaneously, and that leads us to our final product over here.